I first discovered systems thinking in 2022 when I picked up Peter Senge's book, The Fifth Discipline. It completely blew my mind, but I was also confused. I had never heard of systems thinking before, and I couldn't understand it. Why wasn't anyone talking about this? Why wasn't everyone talking about this? The book had been around since 1990, with a revision in 2006. By the time I read it, these ideas had existed for 32 years, and despite all my reading in classes, no one had ever mentioned systems thinking to me before. When I put these concepts into practice, they transformed not just how I thought about my work, but the quality and effectiveness of what I was doing. The results were remarkable. That's why I believe developing the practice of systems thinking is essential for product leaders. My goal in this chapter isn't to deliver a masterclass on systems thinking. That would take far more time than we have. Instead, I want to spark your interest, establish a foundation, and help you see the value in exploring these concepts further. Think of this as an introduction that gives you enough understanding to recognize why systems thinking matters and how it can transform your work as a product leader. In this module, we'll explore what systems thinking is, why it's challenging yet crucial, how it helps us distinguish between systems problems and people problems, and how it connects to continuous improvement practices. By the end, you'll have practical tools to apply systems thinking to your product development challenges, and hopefully, the motivation to continue learning. In brief, systems thinking is thinking about everything all at once, which I know sounds a bit insane. More precisely, it's mapping out the connections between everything within our context. As product leaders, we must consider relationships between our product's features, how they interact with other products in our portfolio, our marketing, social media presence, legal considerations, customer perceptions, and the impact on our teams. It's a holistic approach that considers every decision we make, from the features we prioritize to the meetings we schedule, and even the words we choose. According to Peter Senge, systems thinking is a framework for seeing interrelationships rather than things, for seeing patterns rather than static snapshots. It's the fifth and integrating discipline that brings together his other four disciplines: personal mastery, mental models, shared vision, and team learning. Systems thinking differs fundamentally from linear or reductionist thinking. While linear thinking follows a step-by-step cause and effect approach, systems thinking recognizes complex interactions and feedback loops. Linear thinking breaks systems into discrete elements and ignores broader context, whereas systems thinking embraces complexity and interconnectedness. We practice systems thinking because understanding these relationships and potential impacts helps us anticipate consequences, plan effectively, minimize risks, identify opportunities, and even create positive feedback loops or flywheels that can propel our business forward. To truly understand systems thinking, though, we need to recognize what makes a system a system. Let's explore the key characteristics that all systems share. When we look at any system, whether it's a product ecosystem, a team structure, or a business process, we can identify several defining characteristics that shape how they behave. First, there's interconnectedness. In a product ecosystem, changing one feature can affect user engagement, impacting revenue and influencing future development resources. These elements are all connected in ways that aren't always obvious. Second, systems have feedback loops. These occur when outputs from one part of the system become inputs for another part, creating circular patterns of cause and effect. For example, increased user engagement might lead to more feature requests, which could improve the product, leading to even greater engagement. Third, systems demonstrate emergence. This means they exhibit properties that aren't visible in individual parts. The user experience of your product emerges from the interaction of design, functionality, performance, and content. No single component creates the experience by itself. Finally, systems often display nonlinearity. A small change in one area can produce disproportionately large effects elsewhere. Think about how a minor tweak to a checkout process can dramatically increase conversion rates, or how a seemingly insignificant bug can cause major user frustration. Understanding these characteristics is foundational to effective systems thinking. Unfortunately, Systems thinking doesn't come naturally to most of us. We have several cognitive biases that make it particularly challenging. One is our tendency towards linear cause and effect thinking. Our brains naturally look for simple explanations. This happened because of that. It's much harder to see multiple causes or feedback loops. Another challenge is our cognitive limits. It isn't easy to hold complex systems in our minds all at once. We're wired to simplify and to reduce complexity to manageable chunks. Many organizational structures also reinforce siloed thinking, making it harder to see connections across departments or disciplines. Each team optimizes for its own metrics, sometimes at the expense of the whole system. Time delays between actions and consequences in systems make connections difficult to see. When cause and effect are separated by time, we often fail to connect them. Let me share a recent example from my work. We had a situation where advertisements on a news website were loading slowly. The immediate assumption was that the most recent release had introduced a bug, a classic linear cause and effect assumption. But after investigating, we discovered the real causes. First, a bug in a third-party cloud-based video player, and later, a Twitter outage that had caused a script to time out. Had we rolled back our release, like several stakeholders asked, the obvious solution, we wouldn't have addressed the real problems or made improvements to prevent similar issues in the future. This example illustrates why it's worth developing the discipline to think in systems, even when it's challenging. By mapping connections and considering the whole ecosystem, we can identify the actual causes of problems and implement more effective solutions. One of the most powerful shifts that comes from systems thinking is recognizing that what appear to be people problems are often actually systems problems. W. Edwards Deming, the father of continuous quality improvement, stated that 94% of issues in the workplace are systemic, while only 6% are attributable to individual factors. This has been popularized as the 95-5 rule. 95% of performance is determined by the system, only 5% by the individual. In my experience, nobody wakes up in the morning thinking, I want to do an awful job at work today. Most of the time, when people struggle or fail at their jobs, it's not because they're incompetent or unmotivated. It might be due to a skill gap, an experience gap, or an education gap. But more often, it's because we've built systems in our companies that inhibit success. We've all experienced the red tape and bureaucracy that prevents us from doing our best work. Maybe reporting structures are unclear or approval processes are unnecessarily complex. Perhaps information doesn't flow to the people who need it, or incentives are misaligned with desired outcomes. These are all system issues. Common product development challenges that are frequently misattributed to individuals include late deliveries, quality issues, communication breakdowns, and recurring bugs. When we encounter these problems, our instinct is often to find someone to blame: the developer who wrote the buggy code, the product manager who didn't clarify requirements, or the designer who created a confusing interface. But if you implemented a perfect solution in a broken system, that solution would eventually break too. And if you put your best people into a dysfunctional system, they'll either become frustrated and leave, or their performance will suffer despite their abilities. The benefit of reframing problem analysis from people to systems is twofold. First, it leads to more effective solutions that address root causes rather than symptoms. Second, it improves team morale. When employees feel that problems aren't being targeted at them, but are treated as opportunities for system improvement, they're more likely to engage constructively in problem solving. This focus on improving systems rather than blaming individuals leads us to our concept of continuous improvement, how we can systematically improve our processes, products, and organizations over time. When we recognize that most problems are systemic in nature, the logical next step is to find ways to improve those systems. This is where continuous improvement methodologies come into play and why they pair so beautifully with systems thinking. One of the most powerful approaches to continuous improvement comes from Japan. It's called Kaizen, which literally means change for better. Kai meaning change, and Zen meaning good. Kaizen is a philosophy popularized by Japanese manufacturers like Toyota and Honda, and has since been adopted by organizations worldwide. Years before encountering the fifth discipline, I had read Masaki Imai's book Kaizen, which describes the Japanese approach to continuous improvement. Imai interpreted Kaizen as breaking concepts or practices into their smallest pieces and perfecting them through small, ongoing improvements. The philosophy appealed to me, and I implemented it with good results. Even simple changes, like reorganizing a supply closet to reduce the number of steps employees took to get materials, added up to meaningful improvements over time. But something was missing in my understanding until I combined Kaizen with systems thinking. Kaizen teaches us to break things down into small pieces to understand and improve them, while systems thinking reminds us to map the relationships between these pieces and consider the whole. This combination is powerful because it prevents the danger of optimizing parts without considering the whole. We've all seen cases where improving efficiency in one department creates bottlenecks elsewhere. It helps us identify the right areas for continuous improvement, those with the greatest systemic impact. And it enables us to recognize emergent properties, how improvements in multiple areas can create synergistic effects greater than the sum of individual changes. Fred Brooks wrote that team communication and coordination are a business's most considerable time consumption. Systems thinking helps us identify those boundaries and figure out where the blocks are so we can improve them. By mapping the entire system, we can identify where we'll get the most significant impact from our improvement efforts, ensuring that an optimization in one area doesn't create problems elsewhere. There are several simple yet powerful tools you can start using today to apply systems thinking to your product development challenges. Connection circles help you visualize relationships between elements in a system. To create one, draw a circle and place key elements around it, say features, user needs, resources. Draw arrows between elements to show relationships, and you can use plus or minus signs to indicate positive or negative influences. Look for feedback loops and unexpected connections. Behavior over time graphs show how variables change over time. Choose 2 to 3 key variables to track. Draw a graph with time on the x-axis and variables on the y-axis. Sketch the expected behavior of each variable over time, and then look for patterns and potential cause and effect relationships. And causal loop diagrams, which illustrate cause and effect relationships. Identify key variables in your system, and then connect variables with arrows showing causal relationships. Label the arrows with plus, indicating the same direction, or minus, indicating opposite direction, to show influence. You can also identify and label reinforcing or balancing loops. Another powerful technique is the 5 whys analysis. When encountering a problem, ask why 5 times to determine the root causes. This simple approach often reveals systemic issues that aren't apparent from a surface level analysis. Of course, Wordley mapping, which we covered earlier in the course, is also a valuable systems thinking tool. It allows you to visualize your value chain, understand the evolution of components, and identify strategic priorities based on the systemic relationships between components. If you need a refresher on Wordley mapping, I encourage you to revisit that module. These tools help make the invisible visible. They allow you to map the connections, dependencies, and feedback loops that might otherwise remain hidden. Let's consider a simple example of how systems thinking might apply to product development. Imagine you're facing pressure to ship a feature faster. The linear thinking approach might be to add more developers to the team, but systems thinking would prompt you to consider, how will adding people affect team communication overhead? What impact will this have on quality assurance resources? Will accelerating this feature delay other important work? How might rushing affect the customer experience? And what precedent does this set for future feature requests? By mapping these relationships, you might discover that adding resources could actually slow delivery or create problems elsewhere. Instead, you might find opportunities to simplify the feature scope while preserving core value, or identify process improvements that increase efficiency without adding pressure. This example highlights an important truth about systems thinking that might surprise you. Despite dealing with complexity, it often leads to elegantly simple solutions. When you understand a system deeply, you can identify leverage points, places in the system where a small change can produce big results. For instance, in our feature delivery example, perhaps the leverage point isn't in development resources at all, but in clarifying requirements earlier in the process. A simple change to gathering and validating requirements might eliminate rework and accelerate delivery more effectively than adding developers. And while it may be too late to help in this instance, you can improve how your team approaches work in the future. The power of systems thinking is that it helps you find these high leverage interventions that might otherwise remain hidden. Rather than throwing resources at symptoms, you can address root causes with targeted, often simpler approaches. The key is to make this approach a habit, to consistently ask questions about connections, feedback loops, and whole system effects before making decisions. Start with small experiments in your current work. Before implementing a solution, map the system around the problem. Consider not just the immediate effects of your proposed solution, but its potential ripple effects throughout the system. Systems thinking represents a fundamental shift in how we approach product development. Rather than seeing isolated problems, people, or features, we see networks of relationships, feedback loops, and emergent behaviors. This perspective allows us to identify root causes rather than symptoms, anticipate the consequences of our decisions, discover leverage points where small changes yield big results, create reinforcing feedback loops that drive sustained success, and build more resilient products and teams. While systems thinking can initially feel challenging, it becomes more natural with practice. Start small by applying one of the tools we've discussed to a current challenge you're facing. Map the connections, look for feedback loops, and consider the whole system before implementing solutions. Remember that 95% of performance issues stem from the system, not the individuals. By improving systems rather than blaming people, you'll solve problems more effectively and create an environment where your team can do their best work. In our next module, we'll explore how to create flywheel effects, those powerful, positive feedback loops that propel your products and business forward. You'll see how systems thinking provides the foundation for identifying and building these virtuous cycles. And I encourage you to explore systems thinking further through books like The Fifth Discipline by Peter Senge, or by applying simple tools like connection circles to your current work. The goal isn't to become a systems thinking expert overnight, but to start building awareness of the systems around you and how they influence your products and teams. Even small shifts in perspective can significantly improve how you approach challenges and opportunities.